Today in this video, we are going to study about the load balancer. So now, first of all, we are going to discuss about the monolithic architecture. So in the monolithic architecture, we used to have one single server. This one single server can support up to 50,000 requests per second. And now, there are only 10,000 users. So this server is easily able to support 10,000 users. Everything was pretty sorted. But as internet grows, after 2010, people realized that there is a lot of need of internet. So people started shifting and started using the internet. And now we are going to have 70,000 users. And one single server can support up to 50,000 users. So what we have to do? We have to put multiple servers. So right now we put two servers. So this server can support up to 50,000 requests per second. Another can support up to 50,000 requests per second. Now everything was working perfectly. There was only one problem. So some of the users has to call this particular server and some of the users are calling this particular server. Think of it, these users have to handle it manually. Basically, some of the people are calling one other URL and some users are calling another URL. But this is not the user's responsibility. Users should call only one URL, one single URL. So the load balancer come in. So now whenever a user make a call, they will just call the load balancer, and now it's load balancer responsibility to distribute the traffic across the server. So again, there are 70,000 requests per second are coming from the users. It will go to the one single URL, one to one single server basically. Okay, and now the load balancer will distribute the traffic among the different servers. This is what load balancer do. This is the basic functionality of load balancer. Give the one single URL or one single IP, and after that it will distribute the traffic among all the server that is behind it. Now we are going to talk about the actual definition of the load balancer and what it provides. So the load balancer is a system that receives traffic from the client and distributes the traffic across multiple backend servers that we have discussed. That is the actual definition. And now we are talking about its goals. So it prevents one server from receiving all the traffic. So suppose there are two servers. So when it is distributing the traffic among the servers, it should distribute in a way that one server should not get all the load. Let's say there are 100 requests coming, so not 100 requests should go to this particular server. It should be distributed among these. So basically 50 requests should go to this one, 50 to go to another server. This is what a good load balancer should do. Now improve availability when server fails. So suppose there are three servers behind the load balancer and one of the server dies, then load balancer should not send the request to that particular server. It should send the request to another servers. Basically there are three servers A, B and C. If C dies, then load balancer automatically should detect that C is dead. Now what we have to do, we have to send the request to A and B. Now allow server to be added or removed. Behind the load balancer, we can add more servers or we can remove more. We can remove the servers as well. Let's say there are two servers A and B, so we can add C. And let's say if A goes down, we will be able to remove A as well. So now there are B and C are running. This is a basic functionality of a load balancer. Provide one stable address to the client, basically one single URL or one single IP to the clients. Okay, so that now client's responsibility to just call one URL, and now after that load balancer will take care what we have to do with that particular IP or with the call. This is a basic functionality of the load balancer. Now we are going to see where we fit the load balancer in our system. So there are two types of load balancer. One is network load balancer and another one is application load balancer. Network load balancer comes on transport layer. Application load balancer comes on application layer. So what you guys need to know. So think of it, the request will start coming from the physical layer and it will go up till application layer. And think of it that it is a building. And if it is a building and the transport layer is on the 4th floor and application layer is on the 7th floor. So the guy who is standing on the 4th floor, he can look downwards and can see all the things that are under it. So basically transport layer can see all the details of the request that is coming from the client up to network layer, data link layer and the physical layer. And the guy who is standing on the 7th floor, basically L7 load balancer or the load balancer that is on the application layer, can see all the detail at the presentation layer, session layer, transport layer, network layer, data link layer and the physical layer. This is the basic understanding that you should know. I marked the presentation layer of red color. We are going to do a discussion about it. The basic thing that you guys should know about the TLS. So whenever the request is coming from the internet to our system, this request is going to be encrypted. At at the presentation layer, we decrypt that request. Okay, so we call it as TLS termination. TLS will terminate. Okay, so now we have decrypted the request, and at the presentation layer only, after that presentation layer, we can see the URL, we can see the headers, we can see the body, we can see the form data, and then whatnot. We can see like so many things. So this is something that you should know. At the presentation layer, this thing happen. So think of it, the guy who is standing on the 7th floor, basically on this application layer right now, can see these things. But the guy who is standing on the transport layer cannot see these things. Okay, this is the basic thing that you should know, because presentation layer come on the 6th floor and the transport layer is on the 4th floor. I hope with the help of this terminology, with the help of this explanation, you guys understood that L4 load balancer can see less things and L7 load balancer can see more things, and it can even see the body, form data, URL, params, query params, and whatnot. Now we are going to do a detailed discussion about the L4 and the L7 load balancer. So L4 load balancer known as the network load balancer and the L7 load balancer known as the application load balancer. So first of all, we are going to discuss about what they can see. So think of it, in the L4 load balancer, a person can see source and the destination IP, ports. It is a TCP or the UDP call, connection state and the packet level information. Okay, because at the data link layer, at the network layer, we can see all the packets flowing. The L4 load balancer can see all these things. What L4 load balancer cannot see? Basically a full URL path, parameters, HTTP method, auth tokens, microservices information, basically routings. This is something a L4 load balancer cannot see. Examples of the L4 load balancers are AWS NLB and Linux IP table. And we are going to see these examples also in detail later on in this video. Now we are going to talk about the application load balancer. What application load balancer can see? Application load balancer can see each and everything, because application load balancer sits on the 7th floor. Now, if application load balancer can see each and everything, so basically it can see the full path, HTTP method, auth token, microservices, and I copy pasted this thing. Okay, basically 1, 2, 3, 4. It is here as well. Of course, L7 load balancer can see all these things as well. The only thing is that you guys should know the purpose. So if L7 load balancer is sitting on the 7th floor, the purpose is something else, and if the load balancer is sitting on the 4th floor, the purpose is something else. So of course L7 load balancer can see each and everything, but the basic functionality that we use in the L7 load balancer are related to HTTP path, auth token, microservices, parameters, query params, request body. We work on this thing. We don't focus on source IT, ports, TCP, UDP. We don't focus on all these things at L7 level. This is the basic thing that you should know. Of course, it can see all the things, but we don't use it. For these things, we use L4 load balancer. This is the basic thing that you guys should know. Okay, so I mentioned it here as well. We don't use it for generic raw TCP connections, generic raw UDP traffic, database connections such as MySQL or the Postgres SQL. So think of it. Now, when we are going to connect our service with a database, okay, a normal connection, don't think of a client or a request. Think of there is a server and we want to connect it with the database. Now, in that scenario, what we want to do is that we want to put a load balancer. Let's say there are a lot of servers. So think of it, which load balancer you are going to put. It is going to be L4 load balancer or L7 load balancer. If that request, basically database, is coming with IP and port, you can simply put a L4 load balancer and L4 load balancer will distribute the traffic. There is no need to put a L7 load balancer there. I hope I'm able to make you understand this concept. For the routings, for the URL, for the query params, for more flexibility, we use L7. For the IP and ports, for TCP, UDP, for the internal details of the packets, we go for the L4 load balancer. Example of the L7 load balancers are Nginx and AWS ALB. AWS ALB and Nginx are very famous. I think in many e-commerce websites and microservices, you guys have heard of it, and like people use it like normally everywhere. Now we are going to see first type of L4 load balancer. So L4 load balancer are of two types, pass-through mode and the proxy mode. And we are seeing right now the pass-through mode. So as the name suggests, pass-through, it means that what is going to happen whenever a request is coming from the client to the load balancer will not terminate the request. It will directly send that request to the server. Okay, what I mean by this is, so what I'll do is I'll write something for you. TCP termination. Okay, so at the load balancer level, the TCP termination will not happen. This is what I'm trying to say. The request is coming to the load balancer, and at the load balancer level, we are not breaking the request. We are passing that request as it is to the client. Okay. So the main purpose of the load balancer is to provide one single IP to the client. So basically client is calling one single IP. But now the request is just transferred. Basically the packet is just passed through to the server. They are not making a different connection. So technically it looks like that the client is calling the load balancer, but if you think the client is directly calling the server. So load balancer is just acting as a proxy. It is just providing that connection, one stable IP to the client, but it is just making a direct connection with the servers. This is what is known as the pass-through mode. The thing is, why we use this pass-through mode? Pass-through mode is usually used for speed. Think of it, we are not doing anything. We're just passing the request to the server. If we need a lot of speed, of course we should go with the pass-through mode. And I have also tell you that there is a TLS termination. We are not even doing the TLS termination. So security is also not breaching. We are getting the speed. We are directly connecting the client to the server, and we are able to do it, okay, with the help of this pass-through mode. Okay, how we are going to achieve it? We have Linux IP tables. So see this example. Here you will see there are the IP table example that I have taken. Here you will notice that I mentioned the probability of 50% and the destination server. So basically you will go to the Linux machine, and then that Linux machine will act as a load balancer for you. It has to just access, like it should have the access of the other servers. And now whenever the request will come to the Linux machine, it will not terminate that request. It will directly send it to the server. And here I mentioned the probability of 50%. So 50% request will go to this server, and another 50% request will go to this server. This is how a normal IP table will work. Now we are going to understand about the proxy mode. In the proxy mode, what we are going to do, we are going to terminate the connection at the load balancer level. So basically what is going to happen, if you focus on this diagram here, I will just zoom it, a TCP termination. Now what is going to happen here? Whenever the request is going to come, it will break. Okay, TCP termination will break. Basically connection will break here, and now load balancer will make a new connection from here, and it will call any of the server. So if the connection breaks at the load balancer level, okay, then of course TLS termination is not there. TLS termination, basically we didn't decrypted the request. We just break the request at the load balancer level. So now when the request is break, we are making a new connection from the load balancer. It means that we have more flexibility. When we are making the new connection and we are sending the request to any of the server, we can change any logic here. Basically we can come up with the lot of algorithms. Basically we can implement round robin here, least connection, weighted round robin, IP hashes, random. We can do a lot of things. This is the profit of the proxy mode. The thing is, it is secure. Of course it is slower than the pass-through mode, but we get more flexibility here. Okay, we can just make some logics here, and the thing is, it is secured because we didn't do any TLS termination till now. So for the security reasons, we should go with the L4 pass-through mode or the L4 proxy mode. And for the speed, of course, we should go with the L4 pass-through mode. And for the more flexibility, we should go with the L4 proxy mode. Now how to implement this? See, I have given you 3 examples there: Envoy, HA proxy, and Nginx Stream. Now you can implement it with any of them, but think of it. We have implemented the least connection, and the request is coming, and we are sending the request to this port server 443 or 443, whatever. We can just send it to any of the backend server that are present behind the load balancers. You guys understood this proxy mode as well. We are going to discuss about this least connection, all these algorithms at the end of this video, so don't worry about it. Now finally we reach to the L7 load balancer. That is the most commonly used load balancer that we are using, because this load balancer usually we use for the e-commerce website, for the normal microservices. We simply go with the L7 load balancer. So L7 load balancer what we do, we of course we do the TCP termination at the load balancer level. So this is the first thing that we do. So TCP is going to terminate and a new TCP connection will going to start similarly as that was happening at the L4 proxy mode. The second thing that was happening at the L7 load balancer is the TLS termination that I have discussed with you, that is going to happen at the presentation layer. So it means when the TLS termination happen, now this load balancer can see the request. The load balancer can see the URL. Load balancer can see the headers. Load balancer can see the body. Load balancer has lot of data now. So if load balancer have lot of data, it can make logics on that. So basically at the L7 load balancer comes with a lot of flexibility. So it is more flexible. It can route the request to the actual server. Basically, if I show you this example here, you will notice that if I mention /API, so it is saying that call the order service. If I say /products directly, call the front end servers. Okay, so this is the basic logic behind the L7 load balancer. It has like TLS is terminated, we can put lot of logics there. Okay, so this is a simple example of the Nginx. We can come up with this least connection, we are mentioning the servers, and if we have more flexibility, we can come up with this logic as well. If /API is in the URL, we have to call the order service directly. Okay, so this is the L7 load balancer. This is the concept, and this is the thing that you guys should. Now we are going to discuss this important table. In this table, I will tell you where to use which load balancer. So think of it, whenever there is a payment system, we can go with the L4 pass-through mode. End-to-end TLS. Suppose if we are talking about a security, go with the L4 load balancer any day, because we are not terminating the TLS connection. Okay, we need end-to-end TLS. So for the payment backend, we can go for the L4 backend. For the banking traffic, of course, L4 pass-through, backend controls encryption. For the database traffic, L4 pass-through mode or L4 proxy mode. I've discussed about it, that we have taken the MySQL example, and then we are calling the request. We can go with both of them. Live streaming and or the chat application. Okay, live streaming. So suppose the load is increasing on one server in our chat application. What we can do, if we put L4 proxy mode, we can just route the traffic to another server. Similarly, basically least collection, we can make a lot of algorithms there. Okay, that is what we have studied in the L4 proxy mode. Now for the e-commerce website microservices API, of course, go with the L7 load balancer any day. Simple routing. Okay, let's say if people is calling /product, call the product service, /orders, call the order service. Simple thing that we usually do in our AWS ALB. Now for the large e-commerce platform, we have to go with the L4 plus the L7 load balancer depending upon the requirements. Streaming platform, L4 for stream, L7 for the APIs. So now let's say we want to make a WebSocket connection. Think of it, which load balancer you will use between the client and the server. But which one? L4 proxy or L4 pass-through? Think of it and answer me in the comments. Okay, for the Kubernetes, L4 plus L7 ingress, public entry plus path routing. Okay, so this is the basic table that you guys should know, and that will help you to go deep into the system design. Basically, when interview will ask, you will just simply say load balancer. But which load balancer? Okay, you can specify this thing with a reasoning. Now we finally reach to the last part of this video. In this thing, we are going to discuss about all the algorithms of the load balancers. So there are basically 6-7 algorithms in the load balancer. Some are static, some are dynamic. We are going to see each of them one by one. So first is round robin. So in the round robin, what is going to happen? Whenever the load balancer will send the request, it will first of all send it to server 1, then server 2, then server 3. So I mentioned the request here. So first request will go to server 1, second request will go to server 2, third request will go to server 3. Now fourth request when comes, it will again go to server 4. Fifth request will come, again go to server 5. Sixth request will come, it will go to server 6, and so on and so forth. The only thing is, think of it, the 1, 4 and 7 requests are database calls, like huge database reporting calls, and it will take a lot of time. And this 2, 5, 8 are normal user calls. They are not going to take a lot of time. So that's why the proper distribution is not happening. This is a problem in the round robin approach. So now we are going to talk about the sticky round robin. So think of it, let's say there is a user 1 and there is a server A. So server A already knows user 1 and server A, let's say, already know user 2. So this user 1 and user 2 request will go to server A. This is the main purpose. Let's say if the user 1 request go to server B, it will be able to respond it, but it will take some time. And we, of course, we want to reduce the latency. So this is what sticky round robin comes in. So first of all, the request will go to, of course, in the round robin fashion. Now what happens? Let's say this 147, this server A know 147 pretty well. So next time when the request will come from the load balancer, if it is a 147 user, okay, load balancer will figure it out and it will send it to server A only. And let's say if it is 258, it will send it to server B, because now load balancer know that this server for this particular 258 user will respond fast. Okay, and I want you to say, of course, it is not going to take the user every time. It can be based on the IP, it can be based on the request params and lot of things. I'm just giving you an example how sticky round robin works. Now we are going to take an example of the weighted round robin. The simple example is, of course, there is going to be a simple routing one by one. Now there are going to be weights. So weight is defined on each server. So basically on the first server it is 0.7, on second it is 0.2, and on the third it is 0.1. These weights are static. And how we define these weights? Basically think of it, this machine is small. So we can say that the 0.1 load should go on this machine. This machine is big, the 0.2 load should go on this machine is very big, the 0.7 load should go on this machine. Now what is going to happen in the weighted round robin, that whenever the request will come, the 0.7, basically 7 out, let's say 10 requests are going to come, 7 requests should go to this server, 2 requests should go to this server, and 1 request should go to this server. This works pretty good, but sometimes there, let's say, a lot of loads started coming, this thing can break and that can again cause an issue. So this is known as the weighted round robin. Now we are going to see the dynamic, this hash and the consistent hashing I'll tell you at the end. Now in the dynamic, first of all, we are going to see the least connection. So in the least connection, what is going to happen whenever the request is going to come to the load balancer, it will figure out which server is having the least connection right now. So basically this server has the least connection right now, so it will send the request to this server, and till the time this server is solving the queries or like figuring out the responses, this request will go down and the next request will come and go to this server and this server. So basically think of it, all the request servers will have the equal amount of the requests. The only problem is, let's say if the new server comes, whenever the new server comes, it will start with the 0 and other servers are on 100, let's say on 100 and 100. So the new server come, all the 100 requests will start going to that particular server, and that can cause an issue sometimes. And actually it doesn't happen all the time. We can start that server also with the 100, like with the fake number 100, and then that issue will not happen. But this issue can also happen when there is going to be difference between the two servers. Suppose this is on 100 and this is serving on 10. So basically 40 or 50 requests should go to this server. And think of it, this 50 requests are very high, basically high in computation. So then this server can go down. So this is the only issue in this least connection. Otherwise we can use it. Similarly, we have this least time algorithm. Of course, in this, what is going to happen? The load balancer will figure out which service is responding very fast. So this service is responding very fast. In our case, it is responding in 10 milliseconds. So the request will start going to this server, and when the response time will increase, it will start going to this server and this server. Again, the same thing can happen. Large computation can come sometime and it can cause an issue. Otherwise, everything is pretty sorted in this one as well. So now let's discuss the last topic of this video. So basically when the request comes to the load balancer, there is going to be a hash. We are going to hash the request. Either it can be a user ID or either can it be an IP or anything. We hash it and we divide it with the number of the load balancer, number of the servers that are running behind the load balancer. And whatever the number we get, we will send the request to that particular server. So let's say we get 0, we'll send it to this one. We get 1, we'll send it to this one, 2 to this one. This is the normal hash function that we are going to use in the load balancer. The only problem in this algorithm is a little bit, let's say for example, if we add a new server, then we have to change this hash function number. Whenever we delete something, we have to change this particular server. Okay, we have to change this hash number. This is the only problem in this hash IP. Now, how consistent hashing comes in? Now in the consistent hashing, we just increase the ring size. Instead of 3, let's divide it with 120. In our case, like we are dividing in 120. In general scenario, we can divide it with the int max. And on this line, let's say it is starting from 0 to, let's say, int max, then we'll put the servers randomly on some points. Okay, we put the servers randomly on some points, and whatever is going to happen, let's say if I get the value, let's say 9. So in the 9, it is going to find the next server. Let's say the next server is standing on the, let's say, point 12. Okay, so the request will go to the 12th point. The 12th point, it is showing the db3, basically the server 3. So the request, it will send it to the server 3. Now let's say again we do hash and we do a modulus with the int max, and we get the value, let's say 70. It will send the request to the server 2. Okay, it is always going to be in the clockwise direction, or if you're thinking, imagining a line, then it is going to be on the right hand direction. Okay, let's say if we get the value 100, then it will find the 120th. Whatever server is sitting next, okay, the next server, it will send the request to that server. The only thing that we also do in the consistent hashing is that we make the virtual servers. So what we are going to do, we are going to put some dummy servers also. So these are not the dummy server, these are the virtual nodes. Basically at 0 there is server 1, and there is a 30 and there is a server 2. So what we are going to do, we are going to put one virtual server, and let's say 15. So whenever the request comes, let's we have 25, it will go to server 2. If it is going to be 121, it is going to be server 1. If it is going to be 111, it is going to be in server 4. So basically there is a virtual node, and whenever request lands here, it will route it to db4. Okay, or you can say server 4. This is what I'm trying to say. So we put some virtual node. This is the concept of the consistent hashing, and this is how we implement it. For the consistent hashing video, if you want to study deeply, I'll put the link on the top and you guys can study it. I put all these things on my website. You can just go and read the blog related to the load balancer, and you can study it for your interviews. So this is it for the video, and we will meet in our next video where we are going to study again something related to system design. So thank you for watching me, and bye bye.